Hello, my name is Josh McGrath. I'm the Soil Management Extension Specialist at the University of Kentucky. I'd like to acknowledge my co-author, Dr. Josh Duke. He's the chair and a professor in the Department of Agricultural Economics and Rural Sociology at Auburn University. We really appreciate the opportunity to present in this symposium and all the organizers' efforts in pulling it together. So today I'm supposed to talk about understanding manure relocation from the perspective of the fertilizer-only grain farmer. So real briefly, let's kind of cover the background basics. We know that there are nutrient imbalances that are caused by regional specialization, livestock production in one region and grain production in the other region, and these nutrient surpluses underlie the water quality problems that we need to address. In our presentation, we're going to focus on the Delmarva Peninsula and the poultry industry just as an example. So this is an example of a nutrient balance. This is some work that Tom Sims, Amy Schober, and I did back in 2008. And it represents the phosphorus balance for the state of Delaware. And so we have two balances. One is the orange line, which is the amount of phosphorus produced in manure sold as fertilizer, subtracting what would be recommended on a soil test basis statewide. And the blue line is, again, the amount of phosphorus produced or sold and subtracting what's removed by the crops. And on the vertical axis, we have phosphorus surplus in pounds per acre per year. And then we're covering this 10-year period roughly, that is the beginning of intensified emphasis on nutrient management planning. And so requirement for nitrogen and phosphorus-based planning and introduction of a phosphorus site index for environmental management on high P soils. Delaware is a relatively small state with 3 counties, one major ag county, another county that has a fair amount of agriculture, and then the third has very little, and a very large broiler industry relative to the cropland production. And so when we look at soil test-based balance, this orange line, we see a pretty big surplus, and that accounts for legacy soil phosphorus. So many years of poultry litter applied at nitrogen-based rates or even beyond, and we've elevated the soil test P, and now many of the fields we would expect no agronomic response or yield increase due to phosphorus application. But we're still applying that litter for at least part of the nitrogen requirement. And so we saw a very high surplus before we started nutrient management planning policy there. And then we see a pretty dramatic decrease. So really farmers changed their practices, but we still see litter applied on many of these fields where soil test says we don't need the phosphorus. And so this decrease can be attributed to reduced fertilizer sales, transported manure, and decreased litter phosphorus content through diet changes. But I think that education had a lot to do with this. And so farmers learned that they didn't need starter P when they were applying litter and some things like that. But the really surprising finding of this was this crop removal. And what we saw is that by the end of this period, all of these changes in nutrient management planning, poultry diet, and education had brought us into balance. And people weren't expecting this. We're applying about as much phosphorus as being removed by crops. But because of the nature of phosphorus loss and transport on the Delmarva Peninsula from legacy phosphorus in the soils, this is really the problem, this orange line. Because now we're just applying what the crops remove. We're holding status quo, and that's how the policies were designed, the P-index was designed. But we're not really making any progress forward because we're keeping soil test P elevated because we're not allowing drawdown to occur. Nitrogen was a very different story. We see that the orange and blue lines have flip-flopped, and that in general, we saw a decline in the nitrogen recommendation surplus over this time period. You say, well, look, there's still a surplus, but that's because we use total nitrogen in poultry litter as the addition side. And really farmers, the recommendations say they should only use 50 to 60% of the total in. That was a little complicated for this balance, so we left that in there, and it just shows this surplus over recommendations. But if we took that out, we'd be very close to saying at the end of this period, farmers went from a big surplus, applying more than we recommend, to following the recommendations. There are some imprecision in the recommendations, and so there's always going to be some surplus, on this blue line, right? Because nitrogen use efficiency, if you follow our recommendations, is still probably only, somewhere between 40 and 60% on average. The other thing that we see is that with this crop removal, climate has a big effect. Dry years, big surplus. There's nitrogen left over in the soil post-harvest that can be lost. Wet years, good yield, very little residual soil nitrogen. And so nitrogen's quite different than phosphorus, where this removal-based budget or surplus is what's important to water quality. And so we just have to say, well, why aren't we getting anywhere? And so I've projected out what we should be doing. We're nowhere near this, that we need to be in balance with recommendations. So most of these soils recommendations would be to apply nothing. And then we need to be, when we look at crop removal, then of course we're harvesting a crop, not applying phosphorus. We'd be removing about 30 pounds of phosphorus per acre per year. But the reason we're not getting there is because generally state policy over this time period was designed to maintain status quo. So on the worst fields, they were still allowed to apply crop removal. And then also the environmental management tool, the P-index, didn't kick in until 5 times the crop recommendation threshold. So in other words, that critical level above which the crop, you're not going to get added yield from the phosphorus, it was 5 times that critical level when we kicked in the use of the P-index. Now, that threshold didn't change, but I used to be the soil fertility specialist at Maryland. I left in 2014. And just before then, we released a new P-index. We called it the PMT, the phosphorus management tool. It's still being phased in for adoption, but it was actually designed to start this drawdown process on the worst fields. So moving from applying crop removal to applying nothing on the worst fields. But still, there was still going to be maintenance phosphorus application on fields that are above that crop threshold. And so there really wasn't the political will to move all the way to removing that litter off the peninsula and sending it completely somewhere else. Okay, so coming back to this, then we know what we need to do. We need to move poultry litter. And in fact, we need to move more poultry litter than we currently are. So there are programs that exist. Maryland and Delaware both move about 60 to 66,000 tons of poultry litter per year. But that's only about 20 to 25% of the litter they produce, and it's a cost about $1 million per state, averaging about $15 per ton. Interestingly, the integrators pay about half of this transportation cost. So the average fertilizer replacement value of litter, if you need all the nitrogen, phosphorus, and potassium, is about $38 per ton at the farm gate. And for that farmer who has historically applied a lot of litter, they're getting about $9 a ton just from the nitrogen value. And then with the relocation costs, there's definitely an economic incentive to relocate. But again, why aren't we moving more? And I think it kind of comes down to some personal bias issues and political will. But also, this is where we start to ask, can we use economics to enhance manure movement? So now we're getting around to what I was actually asked to talk about, and that's the demand side obstacles. And what does it look like from the fertilizer-only grain farmer who's in the grain belt or other parts of the watershed? And what are the obstacles? And so we need to understand these. And this is not an exhaustive list, but I'm going to go through some of the principal ones that I can kind of identify easily. So the first is technology. They need new technology to spread the manure. They need a poultry litter spreader, right? And they're going to have to invest money in this, and there might not be a certain supply of that poultry litter. We often hear this complaint, I can get litter this year, but not next year, so why would I buy a poultry litter spreader? And the other option is to have contract spreading. That's largely how litter is applied in Kentucky. Most of the people using poultry litter have not used it before or are not poultry farmers. And so they're paying a third-party contractor to spread that litter. But there are problems with that system because, for example, quite often in Kentucky, I've found that most of the litter is applied in the fall. And that's because that's the only time it's available through these contract spreaders is to apply it in the fall. And as a result, that grain farmer is buying poultry litter and they're paying a premium price for it, but they're getting most of the value they're not getting. And that's the nitrogen value because that's lost over the winter through denitrification. So contract spreading has its own problems, but we need to address these issues with equipment availability. Also technology for on-farm storage and handling. They may not have the machinery or manure storage sheds. And, some of this can be eliminated by investing in manure physical characteristics. So technology surrounding how the manure is shipped and how it is spread. We had a pelletizing plant on the Delmarva Peninsula, but it went out of business. There was talk about compressing litter in bales to be able to put on trucks or trains and ship it out of the watershed. But there are examples where technology or investment has been made in the physical characteristics of the litter. I talked to a gentleman once from Iowa with the layer industry there, and for his company, almost all of the litter from this layer industry was pelletized and shipped from Iowa to either Colorado or California to organic farms. And that was because those organic farmers were willing to pay this premium price that included the shipment cost. And so there was no government intervention. That was just market forces allowing investment in this technology to move it where there was a demand that would pay the price for shipping. I think information is a huge portion of this. We saw the big impact on the supply side that education had in the Delaware nutrient surpluses. But on the demand side, there's this perception that there may be limited agronomic performance with litter for some farmers. Certainly there are some that really want to get a hold of it. But also there's apprehension about the environmental performance. In other words, they say, look, I don't want to be another Chesapeake Bay. I don't want to bring that problem here. And we can alleviate some of this with education on proper usage and the real agronomic benefits and how to avoid environmental detriment. There's also an information about the nutrient content and nutrient availability from manure. Folks, it's very different than fertilizer, and folks who may adopt poultry litter that previously only use fertilizer are going to have to learn the differences in availability and content and how to handle the product. And also soil test-based recommendations might change. The philosophy might shift from a variable rate precision ag approach with close to sufficiency rates to a little bit more of a build component, and the timing and so forth may shift. So we need information there. And then I think these farmers would be more likely to adopt if there was some mechanism for them to get real-time feedback. And by real-time, I mean in the time frame in which they're making management decisions on potential environmental and agronomic impact. So another symposium, I'm going to be talking about models and how we can integrate environmental models with agronomic soil test models. And so the farmer gets this feedback of what are the pluses and minuses and the trade-offs for environmental impact. And so having that information may make them more likely to adopt. And then finally, probably the most costly to that demand side is time or logistics. And so field efficiency goes way down with litter. You're talking 3% nitrogen instead of 30 or 46%. The supply of nutrients relative to crop demand will change. And so they're going to have to change timing of application. They're going to have to bring in, and instead of just doing one shot of nitrogen at the beginning of the season, they may be doing some poultry litter and some in-season fertilization. They're going to have to spend time installing new conservation practices if they want to kind of avoid some of the environmental pitfalls. And all of this is going to require time for more complex nutrient management planning. And then they're also going to have to dedicate some of their logistical effort to either dealing with or kind of this threat of perceived or real regulatory pressure once they adopt poultry litter. And then there are the technical aspects of new BMTP adoption that would be related to manure usage. So all of this is a kind of a logistical expense on the demand side. And so if we look at information, we look at logistics, and we look at technology, these are all things that are going to cost money. For the most part, this is going to cost money. It may be reallocation of resources that are already using, or it may be new money. But clearly, if we're going to move this litter to this farmer and move this fertilizer to this farmer, this is going to cost us money. And so this is where we start looking at the economics of enhance the efficiency of the manure relocation program. The current programs have always focused on the manure side. We figure if we pay for the transport, there's plenty of demand out there, but it might not be the demand that we want. And so we need to evaluate this. And so we propose that programs should be designed to account for that demand side and incorporate that demand consideration into the whole system of supply and demand using economic models. And we can evaluate programs to find increased efficiency. So now we're going to start talking about the economics. So this curve S0 is the supply curve. So this is, let's say, Sussex County, Delaware, where all the poultry industry is. And it kind of incorporates all the technology on the farm and everything that contributes to the value of that poultry litter at the gate in the supplying region. So S0 and D, the area under that curve, is the total value of this quantity of poultry litter that's available in that region. So if we can relocate some portion of that QI out of the region, then the manure value goes up because of supply and demand. And then there's this other curve, D naught, and it describes the function that is the value of the manure at the farm gate of the farmers who would receive that manure. So this is some watershed where manure would have a negligible environmental impact. So now let's look here at S prime. So S prime is the cost at the farm gate to move manure from Sussex County to this demanding farmer. And that distance between S prime and D naught is they're asking, with transportation costs, more money than D naught's willing to pay. And so without intervention, the quantity of manure moved at equilibrium is equal to Q naught, which is 0. No manure is being moved because it costs more than anyone's willing to pay, because S prime is bigger than D naught at any one point. But we know that relocating some quantity of manure would provide social benefit. We'll call it B, environmental, and because it lowers negative water quality impact in the sending region. And so this system is socially inefficient. So even though, economics doesn't push us to make sales, there's this external benefit that this model doesn't account for. So the current transport program generates some sort of Pareto improvement. So the difference between S prime and S naught is A plus B plus C. And by paying that cost of transport, Delaware and Maryland are moving quantity Q1. And so that's about 20 to 25% of the poultry litter. Even though we're paying A plus B plus C, the program actually only costs society C because there's a profit increase at the receiving farm and a profit increase at the sending farm B. And we can assume that the benefit to the environment exceeds this cost C, so there's a net social benefit that is equal to environmental benefit minus the costs of C to society. And we assume that because the program exists. There are challenges and uncertainty associated with manure transport. The environmental benefit may not be immediately recognized by taxpayers. A subset of the beneficiaries might be too small a fraction of that electorate for everyone to get on board with making these payments. There may be people that are grumbling they're paying for something that benefits the water quality just in a small region. Also, legacy nutrients will mask the salience of that environmental benefit. And even beyond the legacy nutrients and latency and hydrology and so forth, there's uncertainty in our estimation of that environmental benefit. So taxpayers might view this as an unwarranted subsidy to agricultural producers. We hear some of the environmental groups saying, hey, look, the farmers shouldn't be getting benefit or this profit B and A. And so these are all some of the challenges associated with these transport programs, but these markets are functioning. We think that we can use economics to enhance program efficiency. Existing programs increase social welfare, so we're going to make that assumption. But a more effective program can be achieved there's three things we're going to focus on: spatially explicit environmental data, incentive-based policy, and increased education and extension efforts. So we're not even going to talk about increasing regulatory burden. And so we would hypothesize that using economic models, we can evaluate and prioritize methods that would lead to a more efficient program. So first, let's talk about public action on the demand side. All those things that we talked about as obstacles. Information, so we can invest in education. The machinery or the technology, we can invest in that. There are examples of this with soil conservation districts, loaning out or renting out no-till planters or cover crop planters to increase adoption of those BMPs. Or we can modify the poultry litter. We can pelletize it. So we can invest in these things, and what will happen is we move D naught to D prime. Okay, so investment in D naught will increase so on the demand side, these investments will increase the price that the farmers, the buyers, are willing to pay. And so doing just this will move equilibrium relocation from Q naught to Q2. Now, depending on the dimensions of these curves, by doing that, D1 may now exceed S1 in some portion of that curve. And so we would have unsubsidized trades occurring up to Q2, possibly. And then in addition, we would increase the subsidized movement because under the current program, we're only moving Q1. But now by moving D1 up from D naught, we are now moving with the same subsidy, A plus B plus C, with a societal cost of C, we're moving Q3. All right. So now we're moving more litter at the same cost. Of course, this will require, this public action or intervention would require some sort of investment. It's going to cost money, and we'll get back to where that comes from. So now on the supply side, we have S naught, and then we have S prime. And S prime is the cost at the farm gate in the demanding region, right? Because that incorporates that transport cost of A plus B plus C. And so current programs pay per unit manure per mile at a capped fixed rate. And these type of fixed rate programs lower incentive to find the least cost trade and may have a perverse incentive that keeps manure closer to the origin. So we're going to invest to move from S prime to S2. Okay, and we're going to do this on the supply side. And so that might mean a more efficient market. So setting up a website like Facebook Marketplace or Craigslist to help buyers and sellers find each other. Okay, we may also invest in lowering the value of foregoing manure in the supply watershed. So supply side education. We saw this in the Delaware nutrient balance, where education made that litter go further. And so by making that litter go further, really what we're doing is lowering S naught and S1, but just for simplicity's sake, it has the same effect of drawing S2 down even further. And so the combination of moving from D prime or D naught to D prime and moving from S1 to S2 moves the equilibrium relocation from Q naught, so that's the current program, to Q4. And then that Q4 is much greater increase than just the Q2 with only one side being affected. And so now we're moving a lot more litter without subsidy. So that's litter now that's moving without government transport payments. But also by moving S2 down closer to S naught and D1 up closer to S naught, we have changed the geometry here such that we have A prime, B prime, and C prime. So the transport cost is actually less. We've decreased the relocation cost that the government subsidizes to move now quantity 3, a much greater quantity. So less money, we're moving more poultry litter. We're not done yet though. This is one I really like, discount shopping. So incentive-based policy. We don't want fair, we want cheap. So we can have the sellers and buyers place bids in the market that match least cost trade so that it's like a two-way auction. The seller puts in their price, the buyer puts in their price, and some manager of the auction or even just software is matching trades that are close in price, because some people were taking advantage of heterogeneity in S2 and D1. Some sellers may have been willing to sell. They want it $15 per ton, but now because they have to place a bid and they really want to sell their litter, they may come down a little bit, give up some of their profit, and they'll put it out there for sale for $10 a ton. On the other side, there are some people that are willing to pay $15 a ton, but there are also some people that say, I'm only willing to pay $10 a ton. And so we start matching these trades, and what happens is the farmers are giving up their profit, A and B. So that's kind of an indirect effect of this. They're losing that subsidy that some people complained about. But also now, instead of the relocation cost, the direct cost to the government, which now is $1 million in Maryland and Delaware, is going to go down to C prime. We're losing that cost of B and C. The farmers are absorbing that loss by taking advantage of this market. And so now we have a lot cheaper program. And then we're also going to get more bang for our buck. We made a more efficient marketplace, but we're also going to design that marketplace perhaps to account for watershed boundaries. And we're going to weight the subsidization to internalize the ecosystem services. So this doesn't change any of the prices. It just increases the benefit from environment to environment 2. So a larger benefit. And so now the total program, here it is, all in a nutshell. At status quo, we were moving quantity 1 with environmental benefit at a cost of A plus B plus C to the government. I'm going to do this in a little bit different order than I presented before, but now we're going to target watersheds. We're still moving quantity 1, but now we're getting environmental benefit 2, so we're getting more benefit, same cost, A plus B plus C. Then we're going to go to that incentive-based market, that two-way auction. It's not fair, but it's cheap, and now our cost goes down from A plus B to C to only C. And we can return A plus B to enhance the program. So now we're going to move from D0 to D1 and S1 to S2 by reinvesting what we're saving, A plus B. Remember, we already had $2 million to play with. And now we're going to move more manure because quantity 3 is greater than quantity 1. And we're only paying C1, which is less than C, and of course less than what we started out with. So we're getting much greater environmental benefit, much lower cost, and so our total savings is A plus B plus the difference between C and C prime. And we take that savings and reinvest in the program. The original program cost, let's call it Z, was A plus B plus C. And so at that original program cost, Z, we were subsidized moving an amount of Q1 minus Q0. But now at the new program cost, which is much less, C prime, we're moving Q3 of litter. And remember that we're moving Q4 from Q0, this whole range, for free, unsubsidized. And so we're only subsidizing the difference between Q4 and Q3, so this region here, at C prime. And so that savings, let's call it Z prime, is equal to Z, original program cost, minus the new cost, C prime. And so now we're going to take that Z prime, which was our savings, and we're going to take some portion of it, Z prime A, and we're going to reinvest it in the program. And that's what allowed us to move D0 to D1 and S1 to S2, right? So we took Z prime A, reinvested it in the program, education, technology, etc. And now we've got Z prime B left over. And so thus, using our original allocation, we've got Z equals C prime, our transportation costs we're currently paying, Z prime A, we're reinvesting to make the program more efficient, and we've got Z prime B left over. Now, I'm going to pause here to point out I think there's probably some skeptics at this point in the audience. Clearly, this is an oversimplification. The curves might not be linear. We don't know what the environment to the benefit is. But I would justify what we're doing here based on, we base this on current conditions of policies, and that there are areas that aren't buying manure, and they should be. And there are areas that are applying litter that shouldn't be. And so we used economic theory, and we know that the slope of S is positive and that the slope of D is negative. So that's good. We might not know how far apart they are exactly. But studies suggest that the water quality is viewed as subpar and not significantly better than it was in the past, which means that the benefit to the environment is probably big relative to the cost of this program. And most important, we're proposing a relocation program of the same scale to what is currently being attempted. So present program. We're not expending any more funds. And this program is small relative to the total amount of manure generated, about 20%. So therefore, we're just talking about taking steps in the right direction to make this program more efficient, freeing capital for reinvestment. And so this brings us to what I think is a counterintuitive finding. We can realize additional benefit because Z1B, what's left over, we reinvested our savings Z. There's two parts. Z1A was reinvested, and that allowed all these additional savings and additional quantity. But Z1B is still left over. And so we can subsidize relocations beyond Q3 and go up to some other quantity, Q5. And this is counterintuitive because it seems in this range, the suppliers would value their manure more than demanders. S0 is above D1, even if we're paying the transportation costs. But if we assume that there's this additional environmental benefit B4 that's greater than B3, and that difference is much greater than the additional costs of both the transport and the premium that now the suppliers are asking, we can buy manure that sellers weren't previously willing to sell. So this is a very important finding because, first of all, we've done this without regulation. Previously, we've talked about tightening up the phosphorus indexes or nutrient management regulations, and so limiting the amount of litter that can be applied in the region S. And then that frees up more litter. But what this has done is, without any additional regulation, we are actually using market forces to free up capital to pay that premium that the supplier, S0, places on their litter. And then we can pay that additional cost plus transport to move it into this receiving or demand side watershed. So this approach is transferable and flexible and scalable. It can improve outcomes in a very small subwatershed, relocating to another small subwatershed. But at a much larger scale, across, say, the Chesapeake Bay watershed, there, of course, would be much larger transport costs, but also larger potential environmental benefit from optimizing these trades. So we know there's a trade-off in watershed scale of how far we move this litter. We don't know what the right scale is, but a planner can begin using this model to think about managing this trade-off. So we're proposing that we need research that quantifies these trade-offs in scale, what interventions in technology and education are needed and what they cost, and market designs that would be most cost-effective. This would also allow us to identify and prioritize future developments like poultry litter injection or on-the-go sensors that analyze the manure as it's being applied and allow for variable rate application. And this is all made possible because we freed up this savings Z through a more efficient marketplace. With that, I look forward to our discussion session. And if you have any questions, feel free to email me. Thank you.